Hey, good afternoon, class. This is Mr. Bean here, and this will be video 4, looking at the night sky. So I'll let you go ahead and read this here, then we'll discuss some things, and you're able to stop the video at any time so you can do some reading or get caught up. This will be slide 1. Okay, here is slide 2, and on here it has the celestial sphere, and this is how it seems on the earth. So what happens is that uh, the earth is spinning here. So go ahead and take a look at figure A here. To a stargazer on the earth, all stars appear equally remote. Okay. On B here, we picture the stars as fixed on a celestial sphere that spins westerly daily, opposite to the Earth's actual rotation. So here's a question here. We want you to answer. We don't really need to see me here. Uh, why do stars on the celestial sphere appear to be moving during the night when you observe them from the Earth? So go ahead and stop and answer this question. Okay. Slide 3 here. We'll let you go ahead and read this here. Okay. Here's slide 4. This is the constellations here. This is Leo. This is what the group of stars look like. And here's Leo the lion. Okay. Here is the Orion Nebula. Right here, it kind of looks like an eagle, but this is the Orion Nebula here. It looks like a bird. And the Orion Nebula is right here on the Orion constellation. Here is the Orion constellation. This is Betelgeuse, and Betelgeuse is right here. It's kind of a red giant star. This is Bellatrix, which is right here. If you're a Harry Potter fan, there's Bellatrix. This is Orion's belt. Here's Orion's belt. Here's the Orion Nebula, which is right here, and this is a close-up of it. This is the star Rigel, which is right here. This is Rigel. And later on, when we're in class, we'll do a closer inspection of the Orion Nebula. Okay. This is a star chart here of the night sky, and will be an in-class activity. And this dashed line is what's called the ecliptic. So the sun actually travels along the ecliptic right here. And notice here, we see along the ecliptic, we see most of the uh, zodiacs. Okay, here's Scorpius, Sagittarius, Capricornus, Aquarius. Here's Aries. Now notice here's Mars, Saturn and Jupiter, which is out right now. You can see Jupiter and Saturn, they're close by. And here's Ophiuchus. Remember, this was uh, kicked out of the zodiac, right? Here's Virgo over here. And up here, here is Ursa Minor, the small bear. And if you look right here, this is uh, there's Polaris, the North Star. Okay, on slide 7 here, I want you to list the 12 constellations of the zodiac. Do a Google search and go ahead and write it down or list them down in Edpuzzle. Okay. Slide 8, star brightness. Okay, I want to take some time on this, and we'll do an activity in class as well. Some stars in the night sky look brighter than others. The apparent magnitude of a sky object is a measure of its observed brightness as seen from the Earth. Stars may look bright because they send out a lot of light, which is called absolute magnitude. Think of it as a wattage on a light bulb, 25 watt, 75 watt, 60 watts, 100 watts, or because they are relatively close to the Earth, which we identify or call as apparent magnitude. Okay. In the 2nd century BC, a Greek astronomer, Hipparchus, divided the visible stars into 6 classes or magnitudes by their relative brightness. He numbered the magnitudes from 1, the brightest, through 6, the least brightest. So the more positive it is, the dimmer it is. Okay, the more positive, the dimmer. Modern astronomers use a more precise version of the ancient classifying system. Instead of judging brightness by the eye, they use an instrument called photometer to measure brightness. And we will do this activity in class as well. Magnitudes for the brightest stars are negative, and so the brightest night star that we can see in the night sky is Sirius, which measures negative 1.44. Magnitudes range from negative 26.7, which is the sun, to about plus 31 for the faintest objects observed in space, in a space telescope. So again, here's the Hipparchus scale. Magnitude 1, very bright star. The size of the circle indicates brightness. Here's magnitude 2.5, magnitude 3, magnitude 4, 5, and 6. 6 is about the dimmest a human eye can see. Now take a look at the scale over here, and uh, here's the sun, negative 26.7 because it's pretty close to us. The full moon is negative 12. Venus, negative 4.6. Here's Sirius again. If you're like in Las Vegas or Reno, you could probably see a naked eye about plus 3. If you're out in the desert, like out in Tonopah or out in Dayton, plus 6 is a dark sky. Binocular, about plus 9. 12-inch telescope is about a plus 14. At the observatory, we have a 14-inch telescope, and our limit is about a 16. And of course, here's the Hubble telescope. So Hubble telescope can see about a plus 30. Okay. Here's this chart here, and I want you to answer some questions based on this chart. So this is a chart showing the brightest sky objects. And notice here's apparent magnitude, which is, remember, based on closeness or location to the Earth. Here's the actual distance in light years. Now, the sun here is 8 light minutes. All of these are light years away. The distance light travels in 1 year. And absolute magnitude, think of it as an actual light bulb wattage. This is the wattage on the light bulb, 4.8, 1.5, so on and so forth. So take a look here at some of the night skies, or some of the brightnesses and distances. So I'm going to ask you a series of questions, and I want you to use this chart and take a look at some things here. Take a look at Deneb. Okay, look at Deneb right here, and notice Deneb is 1,500 light years away. Okay, that's probably on this chart here. That's the furthest away from us. But look at its absolute magnitude. So Deneb is if you look at this chart here, look at this absolute magnitude. Deneb is negative 7.5, which is the most negative. Therefore, it is the absolute magnitude, or the actual brightest star in the nights of on this chart here. But look how far away it is. It is 1,500 light years away, so it appears dim. See how it's 1.25? Okay, so go ahead and answer some questions, and that will conclude video 4.